kind of looking ahead. Test is Friday, and yes, these worksheets are long, but the test is timed for a Friday test, so it's not, it's 1 or 2 problems of each. You'll have plenty of time, I think, to do the test. On the subject of the length of the worksheets, well, a couple things. One is, I was looking back through old AP test, kind of trying to get ready to review at the end of semester. We're doing things a little different. We're going to stick in a week and a half of AP review, kind of just a midpoint review, partially because I don't want to go into integrals yet, because that's a whole nother thing, so we'll wait till next year to do that, and partially because we need some practice on working AP problems. Anyway, in the process of looking at old AP tests, almost every year, maybe not quite that much, but at least every other year, there's a velocity, position, acceleration question in the free response part of the test. So it's a frequently tested thing. So we need to make sure we get lots of practice on those. The other, I don't know, this is just good news. There's not going to be a new assignment on block day. There's not a review. There's not a quiz. Like, we'll do warm-ups, and you'll have time to work on the 3 worksheets that you have. So some of you are like, I'm getting behind already because that's a ton of problems. Okay, I hear you. Don't get too far behind, but it's okay to get a little behind because you'll have block day to work on things. And there's no new lesson on block day. There's no quiz. It's just review, catch up, make sure you're understanding things. In fact, today's the last day of new notes in this section. So, yes, that was quite the lengthy worksheet on Friday, but, reprieve is on the way, I guess. Having said that, let's do a few from that worksheet from Friday.
Can you do 11C? I didn't understand the second part of the question.
Number 11. Tierney? Yeah. Looking at number 11. I don't think we can jump in at C. Let's just work it straight through. When we get to C, we'll slow down and make sure we're okay. Tom stands atop a cliff. He throws his calculus book into the air with an initial upward velocity of 20 meters per second. So V0 is positive 20. As a result, its height in meters above where he threw it. So let's be careful here. This is from where we start. H is equal to negative 5t squared plus 20t. Write an equation for the upward velocity of the book. Well, velocity is derivative of the position. So negative 10t plus 20 would be an equation for the book's velocity. How fast is the book going at time 3? Was it going up or down? Well, let's plug in 3 into our velocity equation. And so its speed is negative 10 meters per second. And so that means the book is going down because it's negative. Because the velocity is negative. How fast is the book going? I kind of don't like that question because we would need to say its velocity is negative 10 meters per second, but its speed is just 10 meters per second because speed doesn't have a direction. So how fast is it going? I'm not sure if that's velocity or speed. So that's kind of a poorly worded question. But it's going 10 meters per second down, or it's going negative 10 meters per second. I wrote that as a separate line because you don't want to say it's going negative 10 meters per second down, because then you've got like two negatives make a positive thing. So its velocity is 10 meters per second, which means it's going down. All right, part C, why you asked the question. At time t equals 3, Was the book above or below where Tom threw it? How far? So we want the height at 3. So negative 5 times 9 plus 60. So negative 45 plus 60 is 15. Well, that's a positive 15. And it told us that h was measured from where he threw it. And so this is a little bit weird, but we're claiming, or we're setting h equals 0 to be the height of the cliff, or the starting point. So if we get a negative, that's okay. That just means we're below where we started. So at time equals 3, the height is 15, and h by definition is how far above we started. So 15 meters above, let's see, how's it phrase it? Above where he threw it.
So the second part, how far, is just
like how far above or below.
Oh, okay.
Was the book above or below, and how far? Well, 15 meters above, because it was positive. Part D, at what time was the book at its highest point? Oh, I'll fix that in just a minute. What do we know about the highest point? Like, how are we going to, what's going on when it's at the highest point? It's maximum. Its height is maximum. What's 0? Derivative of what? I don't have an f. Derivative of h is 0, but derivative of h is velocity, and so you could just jump to velocity equals 0. So you can kind of go the long way and say, well, h is a maximum. That means dh dt equals 0, but it would be helpful if we just knew that at the top, velocity is 0. How long is the velocity 0? Like, we throw a pin up in the air. At the top of the height, its velocity is 0, but how long is the velocity 0? 1 second, 2 seconds, less? Yeah, way less. So some of these, it's just for an instant, velocity is 0. So let's set velocity equal to 0. Move the 20 over, divide by 10. So at t equals 2 seconds, we're at a maximum height, because velocity is 0. Number 2. A ball is thrown vertically upward from the top of an 80-foot building with a speed of 48 feet per second. So h of t, or I guess we called it s of t usually yesterday, is, we're in feet, so negative 16t squared. Thrown upward, so plus 48t plus 80. So I'm going to say the ground is where h is 0, because we're at the top of the building here. And the building's 80 feet tall, but down here on the ground, h is 0. So part A is probably easy. Part B isn't too bad. Part C is okay. Is that, y'all are saying that all of those are okay? It's part D, the time when it hits the ground. Time at ground. So time when s equals 0. Oh yeah, that doesn't look good, does it? Because to solve that, I need maybe factoring, maybe quadratic formula, maybe graphing calculator. All of the above. Can I factor out? I know I can factor out an 8. Can I factor out a 16?
Yes. So then it's
Let's factor out a negative 16.
it gets weird.
Minus 5, I think. 5 times 16 is 80. 3 times 16 is 48. Yeah, so we're good there. That doesn't factor. So I will need to use the quadratic formula. But I'd much rather use the quadratic formula on these coefficients than these coefficients. So factoring out wasn't a waste. It just makes my quadratic formula a little bit easier. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. And again, I'm using the inside coefficients, so I don't have to worry about the big ones. 3 plus or minus square root of 9 plus 20 over 2. Something wrong? Well, it was negative here, so negative negative makes it positive. 3 minus square root of 29 is going to give me a negative number, right? Square root of 29 is more than 5, so I don't have to worry about that one. 3 plus square root of 29 over 2. That would be the exact answer, but that's probably not what we want for this problem. So 4.193 seconds. So another way to do that, especially if you have a calculator, which you would, because otherwise you wouldn't know 4.193, you could go to y equals, and you could put in either one. You could put in this one, which is probably what most people would do, because if you're not factoring, then why bother factoring, right? Just go with that original. So there's our position equation, and we want to know when that equals 0. Let's see, I don't really care about time being negative. Wait, this building was 80 feet tall, so I'm going to go to 100, see if that works for me. Okay, that's good enough for what we need to do. It's thrown off the top of a building, goes up, 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 and then starts coming down. I could adjust the window if I wanted to see the top, especially if it asked me for where does it reach a maximum. Then I could use the calculator to check that. By the way, on the test, I use the calculator. It's fine, but I also want to see the calculus. So did this one even ask when it reaches a maximum? Yeah, the maximum height to reach. So you could, again, I want to see the calculus, so don't only do this. But you can use the calculator. Second calc max. So I'm going to answer part C of this question without doing any calculus. So the maximum happens at 1.5 seconds, and the height is 116 feet. Now the calculus that backs that up, but there's the answer without calculus. Okay, why we did this problem though was to find where it hits the ground, to find the 0. So left bound, right bound, guess 4.193. So we feel good about our paperwork because the calculator backs it up. Second calc 0, and then it says left bound, so that means get to the left of the 0. Press enter. Right bound means get to the right of the 0, and you'll know you're right of the 0 when it goes negative. So I can't really see it, but I can trust and then guess. Just press enter. It thinks for a minute. If you don't like the window, we could have put more below the axis. That way we could have seen the x-intercept a little easier. Left bound, right bound, guess. All right, let's do one more. I think we have time for one more. Emily, did you have a question on one?
Yes. This is one I have the biggest, I'm not efficient on one, but 4, I got like a different.
All right, we'll do 4. And I'll make sure I do other ones later during the day, and I'll post those answers as well if you want to check those. Number 4, a white ball is dropped from a height of 100 feet. Dropped, okay. So H0 is 100, V0 is 0, because we're just dropping it. 1 second later, a blue ball is dropped from a height of 75 feet. So H0 equals 75, V0 equals 0. Which one hits the ground first? Justify your answer. Okay, I think I just want to figure out the time for each, and then I'll compare them, and I'll have to factor in that 1 second thing. So S equals, we're in feet, negative 16t squared plus 100. And this one is negative 16t squared plus 75. And we want to know where they equal 0. So t squared equals 100 over 16. This one actually worked out nice. I square root both of those. You'll have a calculator, but sometimes your brain is faster than a calculator. So it takes 2.5 seconds for the white ball to hit the ground. For the blue one, t squared equals 75 over 16. That one doesn't have as nice of a square root, but we got a calculator. Square root 75 over 16 is 2.165 seconds. But, so we think this one would, well, obviously this one would hit the ground first if we dropped it at the same time. But it was dropped a second later. So from the time we started running experiments, we would need to add a second to this one. And so we would say the white one hits the ground first. Blue hits 3.165 seconds after white is dropped. Yeah, that's right. So if we start the experiment when we drop the white ball, 2.5 seconds later, the white one hits the ground. We wait a second, and then from that second, 2 seconds later, the blue one hits the ground, so that one's not till 3 seconds later. There's a way to work that problem with a t plus 1 or a t minus 1 in there, but I don't think that's the easiest way to do it. I think it's just find both times to hit the ground, and then remember that, well, you waited a second on the blue one, so it doesn't hit the ground first.